In this video, we're going to talk about subsets and about intersection and union. This symbol means is a subset of. It's very similar to the less than or equal to sign. A set A is a subset of B if every element of A is inside of B. Let's see what that means. For example, the set of yellow shapes is a subset of the shapes that we had in our previous video. Why? Well, if you look at the set of yellow shapes, all of them are inside these shapes here in this set on the right. And that's what makes it a subset. I can see this one, and this one. From these three, I can see all of them in this larger set here. Is the set of yellow shapes a subset of the set of rectangles? So let's look. Here's a set of yellow shapes. Is it a subset of the set of rectangles that we had before? Think about it for a minute. The answer is no. So I can put a slash through that. The first set here on the left is not a subset of this set here. And the reason is they overlap. They're not subsets. For it to be a subset, all of these three shapes would have to be in this set here. But the circle is not in this set here, so it's not a subset. How about the set of yellow rectangles? Is it a subset of the set of yellow shapes that I had before? So think about this for a minute. You might want to pause the video and see if you think the answer is yes or no. The answer is yes for this one. The yellow rectangles are all inside the set of yellow shapes. Now, for this one, I want you to think about this for a bit and really pause the video and think it over. One strategy I have for you is S is the set of multiples of 2, a subset of the set of multiples of 4. So I want you to list the multiples of 2 and list the multiples of 4, because then it asks the question the other way around. So I want you to see one of these is true and the other is not. Which one of them is true? And in addition, see if you can figure out if the set of all brown dogs is a subset of the set of all dogs, and if the set of all pets is a subset of the set of all dogs. Even if you don't get all of these right, that's not the point here. The point is to try it out, see how much you know so far. So pause the video and give it a try. So for the first one, the answer is no. It's actually the other way around, so the second one is correct. And you can see why, because if you list them, 2, 4, 6, 8, there's a lot of multiples of 2, and there are fewer multiples of 4. So if you look at the second example, you can find 4 in here. You can find 8 in here, and 12 is also in here if you keep going with the dot, dot, dots. So we would write the multiples of 4 is a subset of the multiples of 2. The set of all brown dogs is a subset of all the dogs because brown dogs are inside the set of all dogs. But the set of all pets is not a subset of the set of all dogs. They overlap. There are pets that are dogs. There are pets that are not dogs. There are dogs that are pets. There are dogs that are not pets. They overlap. It is not true that one is inside the other. Now let's think about this one. What is the set of all 5-sided shapes that we had in our previous video? Now, you might not be able to remember all the way back to the previous video, so I might have to just tell you there were no 5-sided shapes on that slide. So that's the empty set. The empty set, we use the symbol, a null symbol with a slash, an O with a slash through it, or empty curly braces with nothing inside. The one thing I don't want you to do is don't put the null symbol inside the curly braces, because that's a whole different thing. That is a set with something inside it. So it has the empty set in it, no good. Either use this symbol or the empty braces. The empty set is a subset of any set, and we'll go over why as we go along. But here's an example for you to think about. Is the set of all green dogs a subset of the set of all dogs? Think about for a second. Now, wait a second. Unless you talk about dyeing your dog, which is not very nice. If you dyed your dog's fur green, which probably wouldn't be good for your dog. I don't know. Then you would have a green dog. But naturally, just out in nature, we don't have any green dogs, right? But if there were, they would be inside the set of all dogs. So green dogs is an empty set, and that's a subset of the set of all dogs. So that just gives you an idea of why the empty set is a subset of any set. And we would write it like this. Now, we'll go further into this as we go into the next ones, why the empty set is a subset of any set. A set can equal another set and still be a subset. So we're thinking again, the symbol is similar to the less than or equal to sign. This little line underneath indicates they could be equal. There's a special symbol which means that one set is a subset but not equal to, but we won't really use that in this class. Is the set of green and yellow circles a subset of the set of circles from slide 2? So look at the 2. Is one a subset of the other? The answer is yes, because these 2 circles are contained inside this set here. Of course, they're actually equal to each other, right? Those are 2 equal sets. So in that case, we're using this little underlined part that it's okay if the 2 sets are equal. How many subsets does the set of circles from slide 1 have? Now let's review. What are those circles? That's these guys. How many subsets does this set have? Well, first of all, as I said before, the empty set is one of the subsets. So 1. What else? Well, the yellow circle all alone is a subset of yellow circle, green circle. And green circle all alone is a subset of these 2. And what else? Think about it for a second. The set itself is a subset. So how many subsets does this have? I see 1, 2, 3, 4 subsets. And this is another reason to think that it makes sense that the empty set is a subset, because we have the 0 element sets, we have the 1 element subsets, and then we have the 2 element subsets. So it's like counting the size of things. So let's write that down in this chart here. If we have a 0 element set, it has 1 subset. It's just the set itself. If we have a 1 element subset, it has 2 subsets, the empty set and the set itself. And we just discovered this one. If we had a 2 element set, that's what our 2 circles, we ended up having 4 subsets. Let's just remind you back on the previous slide that we counted 4 separate subsets for our 2 element set. So now the question is, if we have 3 elements, how many subsets do you think we're going to come up with? Look at the pattern and make a couple of conjectures and see which one you think is going to come out. So right now, just pencil it down. Think, well, it could be this or maybe this. Those are my 2 ideas. Just put a couple ideas down and we'll see which one works. Pause the slide, put a couple ideas down. All right, let's try out dog, bird, cat. That's a 3 element set, and we'll see how many subsets we can list, and that's going to give us the idea of what the pattern is. So before we go on, see if you can list them yourself. Think of all the 0 element subsets this has, all the 1 element subsets this has, all the 2 element subsets you can think of that this has, and then all the 3 element subsets you can think of that this has. Pause the video and see if you've got it. So the empty set is 1 subset. That's our 0 element subset. Dog is a subset. Bird, all by itself, is a subset. and cat. Those are our one-element subsets of dog, bird, cat. Dog, bird is a subset of dog, bird, cat. Dog, cat is a subset of dog, bird, cat. And bird, cat is a subset of dog, bird, cat. So we have 3 two-element subsets. And finally, the set itself is a subset. So let's count. How many is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 subsets. So now look at our pattern, and what do you think the pattern is? You might have guessed 6 here. You might have guessed 8 here and not been sure, right? That's what a conjecture is. You're making an educated guess. But now that you see it's 8, you know what it's going to be for 4, right? It looks like it's doubling every time. And if you remember doubling, the pattern of doubling is powers of 2. So the formula for the number of subsets is 2 to the n, where n is the number of elements in the set. It doubles each row. So for example, a set with 3 elements has 2 to the 3rd, or 8 subsets. If you go back to the previous slide, the number of elements, let's go back, right? So here, I put this in as the power of 2, and I'll get 8. 2 to the 3rd power is 8. Now, if I have 4 elements, I would do 2 to the 4th power, which would be 16 subsets. Now let's try a couple of last things to talk about before we end the video. The first is complement, and it's pretty basic. It just means not. So, for example, if the universal set, the set we're talking about, is all the students in our class, what's the complement of the set of students wearing black? It's just the students not wearing black. That's it. So complement just means not. Now, we went over a lot of vocabulary. Set builder notation is an element, not an element, subset, empty set, complement, number of subsets of a set. That's a lot of stuff, and we're still going to go over union and intersection. So you may want to pause your thoughts for a second and just try some of these out. I'm not going to spend a lot of time explaining the answers, so what you might want to do is just go through each of them yourself and write them out, and then look at the next slide and see if you got it right. And I'm going to continue on in a second, so you have to pause the video now and try them out. Or if you're super exhausted by all of this, too much vocabulary, just stop, turn the video off, take a break, get a sandwich, come back to this. So here are the answers to those. Take a look at them, pause the video. I'm going to continue on. So this is our last thing, and it's not too bad. So we're looking at some people that I have put into a Venn diagram. And you'll notice, as before with the project, I put everybody only in one spot in the Venn diagram. So James is in this middle between the two because James is in set A and set B. He's listed in both places, and so is Katerina. She is listed in both places, and that's why they're in the middle. Denise and Hannah are not in set A or B, and so they ended up out here. So just remember that for your project. I want to ask you this one. What kind of food do these people like? Look at the A, look at the B, fried food, roasted food. What do James and Katerina like? They like fried and roasted food. This is the intersection or overlap of the two sets, and it's denoted by this little upside down U. I also like to think of it as an N, right? Because it's like the N in intersection. That'd help you remember it. Second question, what do these people like? These people like fried or roasted food, and that's the union. The union is coloring everything in, including the middle part. The union is just everything that's in green here. And we use the word or to describe what's in the union. And so that's pretty much it. Intersection, union, and complement. Remember, you can draw a Venn diagram if it helps. So if you want to have a little bit of practice here, you might try finding A intersect B, A union B, and A complement by drawing the Venn diagram and then seeing where do they overlap, that's the intersection, and where's all of them, that's the union. And the only one that might be a little hard for you is A complement, because this doesn't have a name here like students who are wearing black. So here I want you to just think of all of the letters that are not in A, all of them, all the letters not in A. So pause the video, give this a minute of thought, draw it out, and see if you can find all three things. So A intersect B is this right here, the overlap. A union B is all of it. Whoops, and I went a little too fast there. A union B is all of it, so A, B, C, D, E, F, G. A, B, C, D, E, F, G. And A complement, the one that I said might be a little tough, is this circled part here. All the things that are not in A, but that are in U. So basically anything that's not A, B, C, D, anything that's not those four letters. So that's this area here. That's everything that's not these four things in A. This is A here, right here. And this is the complement. So that's a lot of vocabulary, but what I want to emphasize is it's not a way giant painful amount of thinking. So I want you to think, just try to get used to the vocabulary, get used to using it, and then we'll do a little bit more thinking. And I hope you'll find that sorting using sets is actually kind of fun. See you in the next video.